For more than half a century, one plane has ruled the skies as the undisputed king of speed. It's an icon of the Cold War, a legend cloaked in myth and titanium, the SR-71 Blackbird. Its ability to fly at the edge of space, faster than a rifle bullet, made it seem untouchable, a permanent fixture at the peak of aviation. But what if I told you its reign is finally being challenged? What if the engineering marvel that defined air supremacy for generations is about to meet its match? The story of the SR-71's successor doesn't come from a new stealth fighter or a top-secret space weapon. It comes from a British collaboration that has quietly solved one of the biggest problems in high-speed flight. They've created an engine that isn't just designed to match the Blackbird, but to blow right past it, paving the way for reusable Mach 7 vehicles and a new class of hypersonic weapons. This isn't just a blueprint anymore. This is the story of how a revolutionary ice-cool engine is about to change everything we thought we knew about air power and global reach. The age of the Blackbird set the standard. A new age is about to begin. The legend of the SR-71 Blackbird. To really get the scale of what's happening, you have to understand the legend that's being challenged. The SR-71 Blackbird wasn't just a plane, it was a statement of absolute technological dominance. Born in the secretive corridors of Lockheed's Skunk Works in the 1960s, under the eye of genius designer Kelly Johnson, the Blackbird was built to do one thing nothing else could: fly so fast and so high that no one could ever touch it. Its performance numbers still sound like science fiction. The Blackbird holds the official record for the fastest air-breathing manned aircraft, officially clocked at a blistering 2,193 miles per hour, or Mach 3.3. Unofficially, pilots have hinted at pushing it even faster. It cruised at altitudes over 85,000 feet, on the very edge of space, where the sky turns to deep indigo and you can see the curve of the Earth. From up there, its pilots, wearing astronaut-style pressure suits, could survey huge stretches of enemy territory without a single worry. The engineering behind it was practically a miracle for its time. The plane was mostly built from titanium, a metal so rare and tricky to work with in the 60s that the CIA had to create shell companies just to buy the raw ore from the Soviet Union, the very country the plane was designed to spy on. During flight, the plane's skin would heat up to hundreds of degrees, causing the metal to expand. To deal with this, the SR-71 was actually built with loose-fitting panels that famously leaked its special JP-7 jet fuel all over the runway. It only sealed itself tight once it got up to speed and heated up in the air. And then there were the engines. The Pratt & Whitney J58s were a hybrid marvel. At low speeds, they worked like a normal turbojet. But as the Blackbird screamed past Mach 2, a whole series of complex changes would happen. Huge cones at the front of the engines, called spike inlets, would slide backward to handle the supersonic shockwave, and bypass doors would redirect air around the jet's core. The engine essentially turned itself into a ramjet, with the afterburner doing most of the work. This air-breathing system let it sustain speeds that would literally melt a normal jet. For over 30 years, the SR-71 was the ultimate spy plane. It was untouchable. Legend among its pilots claims that over 4,000 missiles were fired at it during its service life, and not a single one ever hit. The standard evasion tactic for a pilot who spotted a missile launch was simple: just push the throttle forward and outrun it. The Blackbird was faster than the weapons designed to kill it. It was the absolute peak of 20th century aerospace engineering, a machine so far ahead of its time its records stood for decades. It wasn't just a plane, it was the definition of being faster, higher, and The thermal wall. Why Mach 3 is no longer enough. The SR-71's legacy was built on pure, unadulterated speed. But even the Blackbird had its limits. The same physics that made it a legend also created an invisible barrier that has frustrated engineers for decades: a thermal wall. As an object flies, it compresses the air in front of it, and that generates incredible heat. At Mach 3.3, the blackbird's skin got hot enough to cook an egg. But when you start pushing to Mach 4, Mach 5, and beyond, that heat gets exponentially worse. At Mach 5, hypersonic speed, the air entering an engine can hit over 1,000 degrees Celsius, or 1,800 degrees Fahrenheit. At those temperatures, even the toughest alloys used in today's jet engines start to get soft, weak, and eventually melt. This is the core problem of air-breathing hypersonic flight. A conventional turbojet, with its thousands of perfectly balanced, spinning turbine blades, just can't survive that kind of heat. It's why the SR-71's engines were so complicated, and it's why even they couldn't go much faster. They were right at the edge of what materials science could handle. For decades, the only way to get to hypersonic speeds was to ditch air-breathing engines and just use rockets. But rockets have a huge downside. They have to carry their own oxygen. That makes them incredibly heavy, inefficient, and expensive. Most of today's hypersonic weapons are basically rocket-boosted gliders. A massive rocket shoots them up to extreme altitude and speed, and then they glide unpowered to the target. They're fast, sure, but they are one-and-done disposable weapons. You can't use them for a spy mission, have them land on a runway, and fly them again tomorrow. It's a brute force solution. So the holy grail of aerospace has been to create a true air-breathing hypersonic engine. A system that can take off from a runway, accelerate past Mach 5, and then land again, ready for the next mission. That requires an engine that can work like a jet at low speeds, but also survive the furnace of hypersonic airflow. It requires a way to finally break through that thermal wall. And in today's world, the need for this tech is more urgent than ever. The geopolitical scene is nothing like the Cold War world the SR-71 owned. Modern air defenses are smarter, satellites are everywhere, and reaction times have shrunk from hours to minutes. In this new era, it's not just about being fast, it's about being reusably and affordably fast. A Mach 3 plane, while still amazing, isn't the guaranteed trump card it used to be. The world's powers, the US, China, Russia, have been locked in a new arms race to build this kind of technology, but for years they all slammed into the same brick wall, the engine-melting heat. Solving this wouldn't just be an upgrade, it would be a paradigm shift. And that breakthrough has finally arrived, not from some massive American black project, but from a quiet collaboration in the UK. Dawn of the ice-cool engine. The solution to the thermal wall problem is as clever as it is game-changing. Instead of trying to build an engine out of materials that can somehow survive 1,000-degree heat, a British company called Reaction Engines asked a totally different question. What if we could just cool the air down before it even gets to the engine? Now that sounds simple, but it's an absolutely massive engineering challenge. To pull it off, you'd need a heat exchanger so powerful and lightweight it could chill a torrent of superheated air to sub-zero temperatures in the blink of an eye. For years, people thought a device like that was impossible. It would have to be stronger than a jet engine but lighter than a car, and handle temperature swings that would shatter most metals. But reaction engines, working with the aerospace giant Rolls-Royce and backed by the UK government, actually did it. They call it the precooler. It's the secret sauce behind their synergetic air-breathing rocket engine, or SABRE, and it's what makes reusable hypersonic flight possible. In 2019, the world got its first real look at its incredible power. In a test facility in Colorado, the team subjected the precooler to airflow heated to 420 degrees Celsius, simulating flight at Mach 3.3, the SR-71's record speed. In less than 1/20th of a second, it cooled that scorching air right down. The concept worked. That same year, they pushed it even harder, testing the precooler in conditions simulating Mach 5. It took an incoming airflow of over 1,000 degrees Celsius and chilled it almost instantly. This was a landmark moment. The technology could tame the hypersonic inferno, but the real proof came more recently. In a series of tests announced around August 2024, the precooler was integrated with a real jet engine for the first time, a modified Rolls-Royce Gnome engine. This wasn't just a component test anymore. It was a demonstration of a complete hybrid system. This integrated setup was run at sustained ground conditions that simulated speeds equivalent to Mach 3.5, proving that a conventional jet engine, when shielded by the precooler, could operate at speeds that would normally destroy it. This was the moment that validated a whole new class of engine, one that breathes air and beats the thermal wall not with brute force, but with radical new thinking. The implications are just staggering. This ice-cool approach means you don't have to invent some impossible, exotic new metal for your whole engine. You can use more conventional, reliable, and cheaper turbine engines, but run them in a way that was previously unthinkable. It allows for a true combined cycle engine, a system that uses a pre-cooled jet for takeoff and acceleration past Mach 3, before a ramjet kicks in to push the vehicle to Mach 5, Mach 7, or even faster. This is the key to a hypersonic vehicle that can take off and land just like a normal plane. The British team didn't just build a new part, they invented a whole new way to fly. Taming a 1,000-degree inferno. So how does this impossible piece of tech actually work? At its heart, the precooler is a heat exchanger, but one with mind-boggling power and efficiency. Its design is a masterpiece of microengineering. Packed inside a compact cylinder are roughly 16,800 tiny tubes, each one finer than a human hair. If you laid them all out, their surface area would be enormous, yet the whole device is incredibly light. These tubes are made of Inconel, a high-temperature superalloy, and they're arranged in a complex, swirling pattern to maximize their contact with the incoming air. Pumping through this huge network of tubes is a coolant. In the full SABRE engine design, it's cryogenic liquid hydrogen, while in other versions, it's helium. As the vehicle tears through the sky at hypersonic speeds, white-hot air gets rammed into the engine inlet. But before it can touch the delicate core of the jet turbine, it's forced to flow over these thousands of tubes filled with freezing cold coolant. In less than 50 milliseconds, literally faster than you can blink, the heat is violently sucked out of the air. The air temperature drops from over 1,000 degrees Celsius to around room temperature or even colder. The precooler can handle up to 1.5 megawatts of heat energy in tests, enough to power 1,000 homes. The effect is so powerful that despite the inferno raging at the front of the engine, frost can actually form on the components just behind the precooler. This is the ice-cool effect that gives the system its name. It creates a bubble of calm, manageable air that lets the turbine work as if it were just cruising at a leisurely subsonic speed, even while the vehicle itself is ripping through the atmosphere. And it gets even cleverer. The system turns a problem, all that excess heat, into part of the solution. The immense thermal energy that's absorbed by the coolant isn't just thrown away. In the full SABRE cycle, the hydrogen that was used as a coolant is now superheated, and it's then fed into the combustion chamber as highly energetic fuel. It's a closed-loop, synergetic system where every part helps the others. One of the trickiest problems the engineers had to solve was stopping that frost from clogging everything up. When you cool hot, moist air that fast, the water vapor would instantly freeze, blocking the tiny tubes and causing the engine to fail. Reaction engines developed a secret sauce solution for this, injecting a tiny bit of methanol into the intake, which acts like antifreeze and lets the precooler run continuously without icing over. This combination of microtubing, cryogenic coolant, and smart frost prevention is what makes it all work. It just sidesteps the thermal wall completely. While other countries were pouring billions into trying to find materials that could withstand the heat, the UK team just took the heat out of the equation. It's a testament to raw ingenuity, a solution that's as elegant as it is effective. Now that the core technology is proven, the United Kingdom is moving fast to turn it into a weapon. The precooler is the heart of a new, ambitious defense project called the Hypersonic Air Vehicle Experimental Program, or HVX. Kicked off in 2022, HVX is a team-up between reaction engines, Rolls-Royce, the Royal Air Force, and the UK's Defence Science and Technology Laboratory, DSTL. The goal is crystal clear: make the UK a world leader in reusable hypersonic aircraft. The program's aim is to develop an unpiloted, autonomous vehicle that can fly at speeds above Mach 5. At the Farnborough Air Show in 2022, they even showed off a concept design. Known as Concept V, it's a sleek, 9-meter-long drone designed to take off and land on a normal runway. Unlike the single-use hypersonic weapons out there today, the vehicles coming out of the HVX program are meant to be completely reusable, just like a regular aircraft. That one difference is a massive shift in both cost and how you can use it. Imagine a drone that can take off from a base in the UK, accelerate to Mach 5 or faster, cross a continent to a target area, release a weapon or gather intelligence, and then fly back to base to be refueled for another mission just hours later. That's the capability HVX is aiming for. It combines the speed of a ballistic missile with the flexibility of a spy plane. The military implications are chilling. A reusable Mach 7 strike drone would be virtually unstoppable with today's defenses. Its speed alone would make it incredibly hard to track, let alone shoot down. Air defense systems that have minutes to react to a normal fighter jet would only have seconds. This kind of platform could also fly at altitudes in between, where traditional air defenses and anti-ballistic missile systems operate, exploiting a huge gap in our current sensor networks. Plus, the fact that it's reusable completely changes the economics of high-speed warfare. Instead of needing a massive, expensive one-shot rocket for every hypersonic strike, a single HVX-style drone could fly dozens or even hundreds of missions. This drastically lowers the cost per mission and means hypersonic speed could be used for routine operations, not just strategic one-off attacks. The UK Ministry of Defence has said it wants a hypersonic weapon demonstrator ready by 2030, and HVX is the key to getting there. This technology could even be used in future fighter jets. There's talk of using SABRE-derived tech to give sixth-generation fighters, like the UK's planned Tempest, the ability to make high Mach dashes, allowing them to engage or escape from a fight at speeds no enemy could possibly match. The HVX program signals a clear strategic shift. For decades, air power has been about stealth, being invisible to the enemy. This new technology suggests a future where speed is the new stealth. Because if no one can catch you, it doesn't really matter if they can see you. The geopolitical shockwave. The successful testing of this pre-cooled engine sends a shockwave across the global stage. For the last decade, the hypersonic arms race has really been a three-horse race between the US, China, and Russia. Their focus has almost entirely been on boost glide vehicles and scramjet missiles, weapons that are definitely fast, but are also expensive, complicated, and disposable. The British breakthrough in reusable hypersonics forges a totally new, disruptive path. It has the potential to make those first-generation hypersonic weapons look like a technological dead end. While other nations were focused on building a faster, single-use bullet, the UK consortium was quietly drafting the blueprint for a reusable hypersonic rifle. This could give the UK and its partners a distinct advantage in the long run. First, it creates a sovereign European capability in a supercritical field. The partnership between a nimble innovator like Reaction Engines and an industrial giant like Rolls-Royce, with government backing, has created a powerful national champion. This reduces reliance on the US for cutting-edge military tech and positions the UK as a key leader in next-generation aerospace. Second, it could fundamentally alter the strategic balance of power. The era of stealth, which has defined military aviation since the F-117, might be giving way to a new era of speed. The ability to cross the globe in just an hour or two creates a new kind of power projection. It enables what strategists call point-to-point warfare, the ability to hold any target on Earth at risk from your home base, without needing aircraft carriers or vulnerable foreign air bases. A nation with a fleet of reusable hypersonic drones could project force with a speed and flexibility no one has right now. Third, it puts immense pressure on its rivals. The US and China have poured hundreds of billions into their own hypersonic programs. While they're ahead in deploying the first non-reusable weapons, this British breakthrough might force them into a costly and time-consuming change of plans. You can bet the Pentagon is watching this with intense interest. The relative simplicity and potential affordability of a pre-cooled engine, compared to the notoriously difficult and complex nature of scramjets, makes the British approach look very attractive. This is more than just a new engine, it's a strategic enabler. It offers a credible answer to the systems being fielded by Russia and China, and it reshapes the future of alliances. For the first time in a generation, a disruptive technology from outside the US-China rivalry threatens to rewrite the rules of global military power. Hypersonic civilian future. While the immediate focus of this engine is on defense, its long-term potential for civilian life is just as exciting. The same precooler that could power an unstoppable military drone is also the key to unlocking ultra-fast intercontinental travel and affordable access to space. This technology is the direct enabler of the full SABRE engine, which is designed to power a true single-stage-to-orbit spaceplane. A vehicle like the proposed Skylon spaceplane, powered by SABRE, could take off from a runway, use the air-breathing engine to accelerate past Mach 5, and then switch to an internal liquid oxygen tank to act as a rocket, pushing it the rest of the way into orbit. It could then re-enter the atmosphere and land back on the same runway, ready for its next flight. This kind of reusability would slash the cost of putting satellites, cargo, and eventually people into space. It would shift space access from the expensive, disposable rocket model to something more like routine airline operations. That could spark a boom in the commercial space industry, making everything from satellite internet to space-based manufacturing far more affordable. And back here on Earth, this technology revives the dream of hypersonic passenger travel, a dream that mostly died when the Concorde was retired. A business jet or small airliner with a pre-cooled engine could fly from London to New York in just over an hour, or from London to Sydney in less than 2. It would shrink the globe, making international business and travel faster than ever before. Companies like Boom Supersonic are already working with Rolls-Royce on advanced propulsion, and the thermal management tech from reaction engines will be critical for any commercially viable high Mach plane. Even beyond flight, the precooler itself has huge potential. As the world's most powerful and lightweight heat exchanger, it could be adapted for use in hybrid electric planes, high-performance electric cars, industrial plants, and power generation. The ability to manage that much heat in such a small package is a transformative technology all on its own. It's a sword that will forge a new generation of weapons, but it's also a plowshare that could cultivate a new era of global connection and open up the final frontier. The SR-71 Blackbird will always be one of the most incredible machines humanity has ever built. For decades, it was a ghost in the sky, a symbol of untouchable power, flying faster and higher than anything that dared to chase it. It was the absolute pinnacle of 20th century technology, a legacy written in fire and titanium at the edge of space. But every era has to end. The Blackbird's reign wasn't ended by a faster missile or a stealthier jet. It was ended by an idea. The idea that it's smarter to tame the fire than to try and withstand it. The development of a pre-cooled, air-breathing engine is more than just an engineering milestone. It's the closing of one chapter in aviation history and the explosive opening of the next. The path is now clear for a future of reusable hypersonic vehicles, platforms that will redefine military strategy and shrink our planet. The technology that once made the Blackbird seem invincible, its Mach 3 speed, has now been surpassed on a test stand by an engine that's just getting started. The new benchmark isn't Mach 3 anymore. It's Mach 5, Mach 7, and beyond. The age of speed is here, and it will be powered by engines that can conquer the inferno. The legend of the Blackbird is now a revered monument to a bygone era, because the future is learning to fly on a different kind of engine. If you want to stay ahead of the curve on the technologies that are reshaping our world, make sure to subscribe and hit that notification bell. The hypersonic race is only getting faster, and we'll be here to break down every new development. Let us know in the comments. Do you think reusable hypersonic flight is the biggest military game changer of this century? Thanks for watching.